This is what your piece of paper should look like to take Cornell notes for this video. At top, you should have it labeled as 5-1, Linear Equations and Functions. This is also the section that's out of your Holt textbook. You should have the title of the video, which is How Do You Graph a Linear Function? We're going to answer that question in this video. And then remember, in your Cornell notes, you should have at least 2 to 3 sentences for your statements or questions. So you could add another statement or question if you have it from your notes, which is going to go here in a larger section on your paper. I just wanted to show you this so you understand how you should be setting up your Cornell notes, because some of you have great notes and some of your notes need a little bit of work. So please make sure it's set up like this. Okay, the question that we're going to answer in this video is, how do you graph a linear equation? I have 2 quick examples to show you, but before we get there, I wanted to discuss how do you graph a linear equation multiple ways, and you're only going to learn one way in this video. The first way to learn how to graph a linear equation is by using a table, and we're actually going to use a table for this video. The second way is by using slope, if you have the slope, and using a y-intercept. So if you have a slope and y-intercept, you can use that to graph. That also gives a slope-intercept form, which we'll talk about later. And then the third way is if you have a point that is given and you have a slope. If you have point and slope, you can also graph a linear equation. So in order to graph any linear equation, all you need is 2 points on a graph, and then you can create a line. So 2 points on a graph will also create a line for you. Here's our first example. We're going to graph 15x plus 3y equals a 9. And then we're going to tell whether it represents a function by using the vertical line test, or I can show you a different way to pictorialize if it's a function or not. So first thing is we need to pick 3 values for x. If you really want to challenge yourself, you can pick any 3 values for x that you want to plug in. So I'm going to get a negative number, so -1. I'll plug in 0. 0 is always nice and easy to plug in. And then I'll plug in a positive number. So I'll plug in positive, let's do positive 1. There we go. So we only need 2 points to create a line, but 3 is always best. Before we begin using this equation, notice this equation is in standard form, and this equation here is in point-slope form. So I need to get it to look like that. So in order to get it look like that, we need to get the y by itself. So I'm going to first subtract 15x to both sides. This is a review of chapter 2. And we get 3y equals negative 15x plus the positive 9 that's on the other side. Then I'll divide everything by 3, not just 1 or 2, but all 3 things by 3. So this cancels out, and I get y equals negative 15 divided by 3 is negative 5x, plus 9 divided by 3 is 3. And now you can see I get the same exact equation that is in our table. Now that we have our equation solved for y, we can easily plug it in the table and get our points. So the first point I'm going to plug in is y equals negative 5 multiplied by negative 1 plus 3. And so negative 5 times negative 1 is positive 5, plus 3 is 8. So our first point is going to be negative 1 and positive 8. Next we have y equals negative 5 multiplied by 0 plus 3. This is much simpler to solve because the negative 5 times 0 just cancels out to be 0. And so my point here is going to be 0, 3. Try to guess what point that is. I'll give you a hint. It's an x or a y intercept. And then we'll go ahead and solve for this one. So we get negative 5 multiplied by 1 plus 3. Negative 5 multiplied by 1 is negative 5 plus 3 is negative 2. So this point is 1, negative 2. So I have 3 points. Remember, all I need is 2 to make a line, but 3 is best. And I'm going to go ahead and plot those 3 points on our graph to the right. So I have negative 1, and then I go up to positive 8, and there's my first point. And then I have 0, so I don't move on the x-axis, up to 3. So this point right here was actually the y intercept. And then I have 1 and -2, which is down here. So now I have my 3 points. I can connect these to form our line. And our line is graphed. To tell whether or not it is a function, we can actually just draw a line through it. And if it only hits that line once, then yes, it is a function. Yes, it is a function. You could also trace those values. So I'm going to use a different color. Let's use green. I'm going to trace the values of x, and you can see that x is only being used once. So x there, x there, x there, x there, x. X, there's only one value for all x's, right? I'm not going to use x twice. And that also shows that it is a function.